Hi, I am Soumikda and I will be solving question number 2 of homework 5. Now, for question number 2, what do we have been given? We have been given the joint density function which is equal to 1 over a y square x, y is greater than equals to 1 and x is between 1 by y and y. What we need to find? We need to first to find the non-zero definite region of x comma y, and we need to find a such that the given density joint density function is a valid density function. Then we need to find the marginal density function fx and fy, and then we need to verify whether those are valid density function. So now for the first part, to draw the non-zero definite region of fx comma y, we need to determine the range of values of x and y where fx comma y is non-zero. Since fx comma y is defined non-zero only when y is greater than 1 and 1 by y is less than x is less than y, sketching the region of that satisfy this condition. Okay, so condition 1, y is greater than 1. Condition to 1 by y is less than x is greater than y. So a is 1 is less than xy and b is x minus y is get less than 0. So this is x equals to y, this is xy is equals to 1 and y is equals to 1. So this is the non-zero dense range function, non-zero definite region of the density function of fx comma y. Now for the second part, for the given density valid density function, it needs to satisfy the following. First, it needs to be always greater than 0, so a is always greater than 0. Why? Because y is greater than 1 and x is also positive, so a has to be definitely greater than 0 than 0. Then the entire from minus infinity to infinity over the entire range of the density function should be equals to 1. So what we can write, x equals to 1 by y to y equals to 1 say infinity, 1 by ay square dy dx. So simplifying it, it becomes a comes around a equals to 2. Okay. Now for the c part, we need to find the marginal distribution. So for the marginal distribution of fx, we can take the density function with respect to y, and y varies from minus infinity to infinity. But how does y varies eventually? So for x is less than for x greater than 0 less than 1, y is from 1 by x to infinity. Why? Because x is less than y is less than 1 by y. So for x, if x is between 0 to 1, which means y is from 1 by x to infinity. If since y is always greater than 0, greater than equals to 1, so it comes, so a is from a is what? A is 2, so it becomes half for x greater than 0 less than 1. For 1 is less than x less than infinity, it varies from x to infinity normally, so it comes with 1 by 2x square. For the marginal density function of y, the integrating variable is x dx. X varies from 1 by y to y, so fy, so marginal density function of y, it is ln by y square. And these are the plots for the marginal density function of fx. As we can see, till 1 it is half, then it reduces to 0 till infinity, and fy of y, so y from 0 is not valid and 0 y less than 1, and from y equals to 1 to infinity it varies as ln y by y square. Now the last part, we need to verify whether they are density functions or not. So if we take the entire integral of fx, it should come to 1. So which this comes to 1 by 2 plus 1 to infinity 1 by 2 x squared dx, which is half plus half, which becomes 1, which is equals to RH. Also fx is greater than 0 for all x is greater than 1 by y less than y. So therefore fx is a valid density function. For fy to be valid density function, same condition. So 1 to infinity, this also is equals to 1, and also the density function of y is greater than 0 for all y greater than equals to 1. So therefore y is also, therefore f of y is also a valid density function.